You made it to the final video in this Intro to R, the Basics series, where we are going to be talking about numerical and graphical summaries of data. Now, for this video, we are going to be using a data set that I have linked in the caption of this video or the description of this video. But basically, it is a data set that consists of a bunch of data that was recorded in Algeria from two different regions. And this includes data such as the temperature, different types of climate data, and a very important indicator variable, which says there was a forest fire on that day in that region, or there was not a forest fire on that day in that region. Now, like I said, you can find a link to where I got this data set from in the description of this video, but I have already gone ahead, cleaned up this data set, and we are specifically going to be looking at the temperature variable. But before I get ahead of myself, when we are taking a data set from an outside source and trying to bring it into R, there are a few things that we need to consider. First of all, in the first video, I mentioned very passively that we have a working directory when we are working in R. What that working directory means is whenever we save anything, when we're calling upon anything in our files, it's all going to come from that folder that we are working on in our computer. That's our working directory. And the way that we can see what this working directory is we use the function getWD, get working directory. So mine, I have everything in a folder that is titled R tutorials. And we can see that in my files, I'm in R tutorials, and here is my working directory. Now, to set your working directory, you can use the set WD and just put the path name of whatever you want your working directory to be. There is also a button up here titled session. I don't think that you can see that in the video, but when you click on session, this menu pops up and you can set your working directory from here as well. Now, you want whatever file that has your data set to be in your working directory, but if it is not, you can always use the read.csv function and put the file name along with the path of wherever it comes from to read it into your environment. Now, we are going to actually, yes, we're going to use read.csv. And because I'm already in my working directory, I don't need to put any sort of path or anything. So I'm just going to type in whatever I named this data set. Okay. And if you're watching this and I am your instructor this term, this data set can be found on our course webpage as well. So I'm reading my cleaned up data set that I got from the link that's in the description of this video, and I'm going to call this forest fire. So when I run it, now in my environment, I see that there's this data set that has a number of variables that have different types. So we have an integer, we have numeric, and again, integer at the bottom. But like I mentioned, we are interested in the temperature variable. So first, let's take a look at what these first few values of forest fire look like, or the first few rows. So we have day, month, year. Also, all of this data was collected between June and September of 2012. We have temperature, which is what we're interested in. And then we aren't interested in this, but if you go to that link, you'll be able to see all of the variable descriptions. And we will be looking at the fire indicator as well. So this one takes on a value of 0 if there was not a fire and 1 if there was a fire. So what we want is to figure out some numerical summaries of the temperature variable. So what we're going to do is we're going to start with measures of location, which we know are mean and median. Where is the center of this data? The functions are exactly what you think they would be. We're going to take the mean of the temperature column in the forest fire data set. And when we do that, we see that the mean is 32.15. If we do the median in the exact same way, remember to comment, we see that the median is 32. Because these are close to each other, we kind of have a sense that we don't have a lot of skewness in the data. Because the median, which is the center, if we ordered all of the data points in order, is very close to the mean, which is if we added all of them together and divide by the number of data points that we have. So those are our two measures of location. What about measures of spread? We can start off with one that's very popular, the standard deviation. And the function that we use for that is just SD. And we're going to do this in the exact same way that we just did mean and median. We're taking the standard deviation of the temperature column in the forest fire data set. And when we run this, we get that the standard deviation is 3.63 when we run that to 2 decimal places. That's the standard deviation, but in our class specifically, we've talked about a few different measures of spread, including the range, where we take the maximum value, subtract the minimum value, and that will give us the entire range of our data set. To get the maximum value of temperature, we're going to do probably what you think we're going to do, just use the function max. So max of the temperature variable minus min of the temperature variable. And what we end up getting is 20. That's the range of our entire data set. Now, we've also talked about percentiles. And the function that we use to figure out the percentiles is the quantile function, where we first put what our data is, and then we put which percentile we want. Say we want the 25th percentile. So the 25th percentile is 30. And this is the actual value of the percentile, not just the location. What's nice about this quantile function is that we can actually add multiple percentiles if we put them all into a vector. And the way that we put them into a vector, we talked about this in the second video, is using the concatenate function C. So here, for example, if we want the 25th percentile, maybe the 35th percentile, the 60th, and the 90th, and we run this, we get output that looks like this, where we are given these 4 different percentiles. So these are percentiles. Now, in terms of the IQR, the interquartile range, remember, this is the 75th percentile, also called the upper quartile, minus the 25th percentile, also called the lower quartile. So what we're going to do is just use this quantile function, and we'll do the 75th percentile minus the 25th percentile, and we get that it's 5. We've also talked about the 5-number summary, and to do that, there's a very handy function just called the summary function, where we put whatever our variable that we're interested in as the argument in the summary function. And when we run that, we're given the 5-number summary. So we have the minimum, first quartile. Well, we're given the 6-number summary here, the median and the mean, and then the third quartile and the maximum. The summary function is a very nice way to just summarize your entire data, but if you want specific measures, such as the standard deviation, that's not included in there. So it's important to know how you calculate these separately as well. That is it for numerical summaries. And we're going to finish this off by talking about 2 graphical summaries, specifically histograms and box plots. We'll start off with histograms. Remember, these are a great way to visualize the shape of a distribution. And again, we're going to be working with that temperature variable in the forest fire dataset. We're going to be using the histogram function, which is just in base R. We don't need to download any packages or anything like that. And the way that this works is we put our variable there that we want to plot, and we just run this. And the plot, like I mentioned, shows up here. We can adjust these windows as well. Okay, so this is great, but what if I want to change the number of bins that I have? So the number of rectangles that I have. For that, I would use the breaks argument. So in the histogram function, again, we're looking at the temperature, and I would use breaks. The number of rectangles is going to be whatever I set breaks to be plus 1. So if I set breaks to be 4, then I'm going to have 5 rectangles. Let's see what that looks like when we run that. So it looks like that. If I want more, say I want breaks equals 30, we can see that for this data set, maybe 30 is too much. And we've talked about this in class. The kind of rule of thumb is that you want between 6 and 15 bins or rectangles, intervals, whatever you want to call them, in your histogram. That's kind of the sweet spot. 4 is a little too little. Yes, we could see some patterns here, but some patterns could be hidden in this 30 to 35 interval, because that's where the bulk of the data is placed. When we have breaks equals 30, there's too much space, and the histogram is not sufficiently filled in. Now, something else that I want to talk about is adding titles. Here, the x-axis is just going to take on whatever you put as your data, and then your title is always going to be histogram of whatever your data is. But if we want to change the title, which we should, to change the main title, we use the argument main, and we put our title here. So temperature in 2 Algerian regions, summer 2012. And we see that it looks like that. Our main title is changed. If we want to change our x-axis title, we can use xlab. So x label. If we wanted to change y-axis, it would be y label, ylab. And again, any text that we're writing, we put that in quotations. So this is just going to be temperature in Celsius. So we run that, and this looks a lot better. Maybe I'll capitalize this and this. Yeah, that looks great. One more thing that I want to mention is on the y-axis, we have frequency. If we want to change that to relative frequency, then we just use the argument freq, F-R-E-Q, equals false. Oh, we don't need to put that in quotations. And then we would have the relative frequency or otherwise called the density on the y-axis. That's it for histograms. The final thing that we're going to talk about is box plots. And to plot a box plot, it's just called the box plot function. And just like with the histograms, we put whatever variable we're interested in and run it. The box plot doesn't automatically come with titles, so we're going to add them in the exact same way that we did for the histogram. So this is going to be temperature in 2 Algerian regions, summer 2012. Now, here we have the box plot vertically. We can also show it horizontally. By just using the argument horizontal equals true. And then it shows that way. So if we go back here, the y-axis is not labeled at all. So again, here we can use ylab equals temperature. And that's our box plot. But we've talked about how a big advantage of using the box plot is that it's very easy to compare two groups. So I mentioned this when I first introduced the data set. We are going to be looking at the fire indicator for the two groups. So we're going to be looking at observational units in our data set where a fire occurred compared to those where they did not occur, and look at the temperature between those two different groups. The way that we group these is we have the variable that we're interested in, temperature, and then we put this tilde and put whatever our grouping is going to be. So here we're using fire indicator, where it takes on a value of 0 if there was no fire, 1 if there was a fire. We're going to put our title, summer 2012. Okay. We're going to put our Y label, which is the temperature, and then the X label, which is going to be the fire indicator. And when we run this, we have the fire indicator, which is the grouping variable, the temperature on the y-axis, our nice table, or our nice title, and this beautiful box plot. That is the end of the Intro to R, the Basics series. So thank you for watching if you made it all the way to the end.